Okay, let's give you guys some more practice. So come up with the Cartesian equation from these parametric equations from 0 to pi, and also draw the diagram and also the path as well, the direction of the path. So press pause and have a go. Okay, so to do this, we are aiming for this identity here. Even though you've got a strange bubble here and a strange bubble here, you can still use this identity because if you look at the real number line, let's say 0 minus infinity to positive infinity. Well, if you have exactly the same, let's take this point here, 3. Uh, 3 here, exactly the same, then this thing here will be 1. If you put in, let's say, I don't know, negative 3 pi over 7, uh, uh, if you put it into here, negative 3 pi over 7, and then if this is exactly the same, negative 3 pi over 7, then this thing here will be true. If you put in, let's say, any number along this line, if this is the same as this, then this whole statement will be true. So if the whole if this statement holds true for everything on this real number line, then this it must hold true for this as well, because as you're putting t into here, this ultimately will turn into a whole number. It will be a whole number. This, when you put t, when you put hang on, when you put t into here, this will ultimately be a whole number on that real number line, and these two are exactly the same. So therefore this should still be true, even though this thing is strange, the bubble here is strange, the bubble here is strange, we can still use this as long as these two are the same. So looking at this, we can square this side, so this will be x squared equals cos squared or whatever here, and then y squared equals sine squared whatever here, and then because these two are exactly the same, we know that this will be true. So 1 equals, let's put this, well, put this into this bit here, so that would be x squared, and then put this into here, so that would be plus y squared. This is an equation for a circle. So even though it's strange, it will still give you the path of the circle. The only difference is that the time will be out of phase. Basically, you don't know which direction, and you don't know which well well even though this thing here and this thing here, even though they're strange, it will still trace out a circle. The only difference is that the time will be out of phase. So now let's try and find the starting position. So put, when time equals 0, put it into here. So that would be cos of pi. Well, cos of pi will be negative 1. So x, well, when time equals 0, x will be negative 1. So now put the 0 into here. So that will be sine of pi. Well, sine of pi will be sine of pi will be 0. So so sine of pi will be 0. So when time equals 0, when time equals 0, then x will be negative 1, y will be 0. So this is your starting position here. That's for when t equals 0. Now for t equals pi, well, for t equals pi, then put it into here. So that would be cos of 0. So when t equals pi, cos of 0 will be 1. So x will be 1. And now put the pi into here, and then that would be sine of 0. Sine of 0 would be 0. So y would be 0. So that would then, when time equals pi, then x will be 1, y will be 0. X is 1, y will be 0. So it's here. So now, will it go this way? will it go this way or will it go this way? So maybe select a time in between and test it out. Okay, test it out for yourself. Okay.